Hello everyone, my name is Shaun Levick, and today I'm going to guide you through our next tutorial looking at using Google Earth Engine as a platform for analyzing remotely sensed imagery and analyzing patterns of change over time. For today's lab, I'd like you to go to lab number 4 on my website, also available through LearnLine. So this is the environmental monitoring and modeling course that I'm teaching at Charles Darwin University. Today we're going to cover the first part of this lab, looking at image classification. So the full objective of this lab is to explore some more advanced features of Google Earth Engine and accomplish a range of image analysis tasks, including supervised image classification, terrain mapping, spectral unmixing, and phonology models. For this recorded video, we'll be focusing on the first point, the supervised image classification. I'd like to start with a few acknowledgements. This wouldn't be possible without the Earth Engine team, who've done a fantastic job of building this platform, as well as providing some great documentation, the Earth Engine 201 Introduction to Advanced Features. So the scripts that we'll be using today come directly from Earth Engine 201, but we'll modify them for our own area of interest. So open up, suggest that you have this page open in one tab and your Earth Engine console in another tab. Go to the address code.earthengine.google.com. If you have an existing script, just clear the space so that we can work in a fresh script. Now we're going to start looking at how to classify an image. Over the last few days we've looked at ways of finding and mosaicing imagery, and now we're going to explore options for classification. There's some great tools within Earth Engine, but for today we will look at a standard supervised classification approach. The first step is to get a cloud-free image from which to work. We can do this by loading Landsat 8 top of atmosphere imagery, spatially filtering a region of interest, temporally filtering for a date range that we're interested in, sorting by cloud cover, and getting the least cloudy scene. So we're going to start by defining our region of interest. For today, let's head back to Darwin, where Charles Darwin University is based, and let's zoom in a little bit closer. For today, if we flick to the satellite view, we can have a bit of a view. We have the city center down here. We have quite a range of different land cover types. I think this will be a good site for this tutorial. And our first task is to create a region of interest. We're going to do that with a teardrop geometry marker. And we'll just place that anywhere in this scene, and I'm going to rename that ROI. So that's over here. It's a geometry variable which we are renaming region of interest. Hit enter. We have the coordinates of that point. So that'll be useful for filtering image collection by location. Can zoom out a bit, a little bit further, and let's look at the next step. Now this is a little bit different to the way we've been doing it previously. So in our previous tutorials, if we wanted to import Landsat 8, we would type Landsat 8, and this would come up. We'd have the option of importing the Landsat 8 top of atmosphere product. However, if you already know the name of the collection, let me just show that again. We have the collection image ID located down here. So if you already know that, you don't need to go through this step. You can write it straight into your code. And that's what Google team have done here. So let's copy these lines and paste them in here. And remember to write some comment lines so that you remember what we're doing. So we use 2 forward slashes for comment lines, and in this stage we are filtering the image collection. So that's the identifier for the Landsat 8 image collection, and we have a few filter criteria here. We have the dot filter bounds. This is defined as ROI, region of interest. That's to match the point that we have created here. Filter date, 2015, 1st of January to 31st of December. So we're looking for any image. We're going to be loading up a collection of images collected during the whole year. But we're going to sort by cloud cover. We don't want images with lots of clouds in them. And after we've sorted, we're going to select the first image from that collection. So basically, we're asking Google to find us all the Landsat 8 images that were collected in 2015 over Darwin and return to us the least cloudy image. If we want to add that to our map, we use the map.addLayer function. Please return the image and the band combination, band 4, 3, and 2, that relates to the wavelengths of red, green, and blue, so it'll create an Rgb composite for us. So let's hit run and see what happens. It takes a little while to search through the collection, but after a short time we'll see a new image coming over our point. Let's zoom out a little bit and we'll be able to see the shape of that Landsat scene. Zoom in a bit, and remember that you have the layers tab over here. We can flick that Landsat image off and on as we like. Come in a bit closer. Landsat spatial resolution is of course at 30 meters, which is quite a bit lower than the background image we have behind us, but it has the advantage of global coverage, much better spectral properties, and a long history going back, or the Landsat program going back to the 1970s. Okay, so we have our image loaded. What's our next step? Second step is to collect training data. So let's follow these steps. Using the cloud-free scene as guidance, hover on the geometry imports box next to the geometry drawing tools and click Add New Layer. Each new layer represents one class within the training data. For example, urban. Let the first new layer represent urban. Locate points in the new layer in urban or built-up areas, such as buildings, roads, parking lots, etc. And when finished collecting points, click Exit and configure the import top of the script as follows. Name the layer Urban, click on the icon to configure it, import as feature collection, add property, land cover, and set its value to 0. Subsequent classes will be 1, 2, etc. So let's get started with that. Basically all that's saying is that we want to build up a training data set, and so far we've used the geometry imports to define our region of interest, but let's add a few others. So let's add a new layer. See, that'll come up here. Geometry, we'll do it slightly differently. We'll name this urban, and since we have this box open, we can just switch that import type to feature collection here and add the property. What you're spelling here, let's call property land cover, because we're going to make a land cover map, and the first value will be 0. We can say OK, and now basically what we want to do is collect some sample points. so that we can teach the algorithm what certain land cover classes look like. So for example, now we can let's collect 10 points for each class. So we zoom into different parts of the image. Let's use zoom a bit further out. So all these white, very reflective points representing urban areas. Let's click on those, and we can see how many points we have here. In urban, we currently have 6 points. Keep clicking. Let's navigate to a different part of the image. Add a few more over this side. We go back to the teardrop. We're still on urban. There we go. It's mostly just buildings that I've selected, but that's okay for these purposes. Another layer. This time, a lot of this image is water. So let's make one of our classes water. Change that to feature collection. Add the property. Remember, we're doing a land cover classification. Let's give this a value of 1. Say OK. And now we need to collect 10 points in the ocean, in all the water bodies. There's a bit of spectral variation in the water with sediment, so let's collect a range in our scene so that we can train the algorithm to know what water looks like. It's going to be a relatively simple classification first off, so we'll just add one more class, and let's call that vegetation. What is the feature collection, property, land cover, and this one's value will be 2. Okay, we need 10 of these. Let's get some coastal areas, mangroves, lots of mangroves here in Charles Darwin Reserve. Couple of golf courses maybe, some other areas out here. Just want a range of different vegetation types really, so that we can build up a spectral library of what vegetation looks like. Okay, when that's done, we can exit the point drawing tool, and let's zoom out to broader area. So we have these geometries imports shown on here. Ideally these would be more widely distributed through the image that we're trying to classify, but I've just focused on that CBD area for the purpose of this exercise. So coming back to our tutorial, let's see, repeat step 2 for each land cover class. That's what we've done. And then what we're going to do is create a new variable called new feature collection. And basically this is just like a merge in any GIS package. So let's write a little note to ourselves. Merge the feature collections, and you'll note here that this is kind of a default merge, geometry dot merge with geometry 2 and merge with geometry 3. Now these are kind of just standard settings. We need to update this. Our first feature collection geometry is urban, so we'll rename this urban, and we want to merge urban with geometry 2, which is water, and we want to merge that with vegetation. So vegetation, this is just for the purposes of building the training data set. So let's run that, check that we don't have any errors. Okay. we've successfully created that new feature collection. Optional, print the feature collection and inspect the features. If we want to do that, we would just say print new feature collection, and that should just add it to our console. It gets printed here. See that there's 30 elements because we've defined 3 land cover classes, and we collected 10 features in each. So if we can have a look at our different features, and basically we just know the land cover value that we've given them. So we have they're identifiable by the numbers. So we've given 0s to urban, 1s to water, and 2s to vegetation. Now our next step is to create training data by overlaying the training points on the image. This will add new properties to the feature collection that represent image band values at each point. Basically, what we want to do is drill down through each of these points, through the multiple bands of the Landsat image, to collect the reflectance values at each point. So to do that, we copy this script and the note to ourselves, just create training data, let's paste that in. We start by creating a variable bands, and we're going to use bands 2, 3, 4, 5, 6, and 7 from the Landsat image. We're going to create a variable called training, and from this we're selecting bands and sample regions from the collection, new feature collection, which is what we've defined up here. We want to base this on the properties land cover. So let's give that a run. No errors. Let's see what's next. We can print the training data. That feature collection won't be any different, but what we can do here is now print training, and that should come up in our console. Feature collection, features, properties, and basically now for each point that we have created, we now have values at that point which give us the reflectance value of the different bands. So for band 2, 3 through to 7, we have a collection now, so that's our training data set. So let's move along to our next step, which is to then train the classifier. So we've collected training data, but now we actually want to train a classification algorithm. And we're going to use a classification and regression tree approach, CART. We should be able to just run this. So we're creating the variable classifier, calling the Earth Engine classifier CART function, training. And if we run with that, everything should work quite smoothly. And we've now trained the classifier. The next step is to run the classification. Let's copy in this piece of code, paste, run the classification, variable classified equals image, select the bands we want and classify them. Let's run with that, check that we have no errors, looking good. Now our last step for today is that we want to display the results. Note that we might need to adjust the colors. If the training data have been created with urban 0, other colors 1 and 2. The result will be rendered in those classes as red, green, and blue, respectively. So let's copy that, paste it here, and click Run. And it takes a little while to come through, but here is our classification. Colors don't make complete sense for us because it's just the order that we have put them in. So we arrange them with urban, water, and then vegetation. You'll note that this palette just makes use of HTML color codes. So if we wanted to change HTML colors, we can just search for HTML color codes and go to the website htmlcolorcodes.com. And now if we want, say, our urban areas to be in black, well, black's actually an easy one, 6 zeros, we just copy that, paste it here. If we want our water to be blue, choose the shade of blue we want, copy the color code, paste it in there, and vegetation, let's make it a darker shade of green, copy the color code, paste it here, and let's run that. So let's have a look around. I've done a pretty good job of classifying land from water, although we have definitely some problems in the city here. A lot of the darker urban areas have been classed as water. That's obviously not correct, but as a first cut, that's not bad. What we would need to do is create more classes, which we could then train the image more thoroughly. And we've only used 3 classes here, so we could increase the number of classes we have to get more detail within the city, for example. If we move out over the more rural areas, we see that we've done a pretty good job in classifying these river systems, for example. Pretty nice. If we look at the layers tab, we have layer 4, which is these, if we want to switch off these geometry imports, we can just close those so that those aren't on our image anymore. But if we want to know where our training points were, we can flick that on using layer 4. Now, obviously this can be improved by using better training data, collecting more training data. Think about some of the other things that we could do to improve this classification. One would be that we've selected a single Landsat scene now. We could do a better job if we made use of a time series. That's it for this section. Hope that made sense. I'll do a follow-up on that with some other classification techniques. But that's all for today. Thanks for watching.